Okay, welcome back, Stella. In this video, I'm going to show you the second method. I'm going to show you the second method on how to integrate this. Okay, so before showing you the method, I'm going to remind you something. Let me go on a new sheet of paper. Okay, you did trigonometry, that's it, and you were taught for example, that if you have an expression a cos x plus or minus b sine x, you can always turn it into an expression of the form r cos x minus alpha plus or minus alpha. Wait, let me write this. You can always turn it into an expression of the form r cos x minus alpha, or you can turn it into an expression of the form r cos x plus alpha, or you can turn it into an expression of the form r sine x minus alpha, or you can turn it into an expression of the form r sine x plus alpha. So these are the different forms in which you can turn an expression of this form. Now, how do you do that? Let's go into the thing. Let's say I'm going to take only some situations. Let's say, for example, we want to turn a cos x plus b sine x into, let's say, we want it to be identical to what? That's the thing. We want it to be identical to r cos x minus alpha. Is that okay? Don't forget that I'm going to say something here. Don't forget that cos x minus alpha is also the same thing as cos alpha minus x. Why? If this cos x minus alpha is the same as cos what? Minus into alpha minus x. Is that okay? But you know that the cos function is an even function. So this is the same thing. Cos, we know that cos of minus x is equals to cos of x. So this becomes back equals to cos of what? Alpha minus x. Is that okay? So let's come back to this. Our aim is to transform this into this. So we want this to be identical to this. The first thing I do is what? I will develop this. This would be identical to r into what? I use transformation trigonometric formulas. So this will become cos x cos alpha plus sine x sine alpha. Is that okay? Now, this implies our a cos x plus b sine x will be identical to what? R cos alpha cos x plus r sine alpha sine x. What do you notice about these expressions? You notice that there is cos x here, there is cos x here, there is sine x here, there is sine x here. So for this expression to be equals to this expression, what do we need to have? Firstly, the first condition is r must be equals to the square root of what? This a square plus b square. You take the b, you take every number with sign. So let's assume here our a was positive. So we have a square plus b square. Is that okay? Now, what will be the next thing? If there is cos here, cos x here and cos x here, if there is sine x here and sine x here, for this expression to be equals to this, it simply means that a must be equals to what? R cos alpha, and b must be equals to what? This b must be equals to what? R sine alpha. Is that okay? This then implies what? It implies that our r will be equals to the square root of a square plus b square, and our cos alpha will be what? Will be A on R. Don't forget R is the square root of A square plus B square. Is that okay? And our sine alpha will be equals to what? B all over R. Is that okay? Look at something. If you come and substitute, if you take this sine, this is the same thing as B all over the square root of A square plus B square. And this is the same as A all over the square root of what? A square plus B square. Is that okay? First, look at what I'm doing. I know you are asking yourself, but how will this help us? You will see how it is going to help us when I will dive into the exercise we are supposed to do. Now, look at something. If I take this cos, this expression, I put it here. So our cos alpha is equals to what? We said our cos alpha is B all over R. Is that okay now? Our sine alpha is what? Our sine alpha. So if we replace this by B all over R, and this sine alpha by what? Our sine alpha, no, our sine alpha, our cos alpha is A all over R, and our sine alpha is what? B all over R. What do you notice? This R will come in. It will cancel this R. Is that okay? It will cancel this R. So this R will go with this R, and this R will also go with this R. We will be left with what? We will be left with what? The A will stay here. We will be left with A. We'll be left with A cos X plus what? B sin X, which is the same thing as what we had here. So doing this transformation, so you see that we have the right to do this transformation. Is that okay? From there, our main, to convert this to this, our main aim is to find R and what? Alpha. So this implies our R will be equals to what? The square root of A square plus B square. Here is something you should note. Never you decide to use either sine alpha to find directly alpha or cos alpha to find directly alpha. Never do that. To find alpha, what you are supposed to do, you divide this sine alpha divided by cos alpha. Sine alpha divided by cos alpha will make what? Tan alpha. So we're going to have what? This B on R divided by this. I'm going to have B on R divided by what? A on R. That will give me what? This will interchange and I will have B on A. So this implies your R will be equals to what? The square root of A square plus B square. And your alpha will be what? The tan inverse of B on A. Don't cram this. I say don't cram this. Use the approach I'm using. If my aim is to convert an expression of this form into this form, what I first write is what? A cos X plus B sin X must be identical to what? What I want to convert it to. What I do next is what? I'll say this is identical to what? I'll develop this one. I'll have my R outside. I'll develop this one. This will give me this. From there, I'll write this being equals to what? I'll bring my R outside. My R inside. This will be R cos alpha cos X. I write it exactly in this form. R cos alpha cos X plus R sin alpha sin X. I know that alpha is a real number, so all of this will be a real number. All of this is a real number. Is that okay? From there, I'll let R to be equals to what? The square root of what? This square plus with its sign plus this square with its sign. That will give me this. And the next thing is what? I'll equate this A to what? This, because in fact, I'll just compare. If there is cos X here and cos X here, then this A must be equals to this R cos alpha. Since there is sin X here and sin X here, then this B must be equals to this. From there, I'll do all this gymnastic. So I'll make cos alpha the subject, which will be A on R, and sin alpha the subject, which will be B on R. From there, I'll have R being equals to this, and to find alpha, I'll divide sin by tan. So I'll have tan alpha being equals to what? This divided by this. From there, I'll have my R and my alpha. Is that okay? Then the same thing, let's say for example, you want instead to convert this let's say for example, you want to convert a minus, let's say a cos x minus b sine x into, let's say for example, into this. So your aim is to convert what? A cos x minus b sine x. Your aim is to convert this. You want it to be identical to what? You want it to be identical to r sine x plus alpha. Let's say you want this. That's our aim. So what I will do is what? I will say this is identical to what? R into what? I will develop this. This will be sine x cos alpha plus cos x sine alpha. Is that okay? So this implies my a cos x minus b sine x will be identical to what? What starts here is cos. So I'll find the term that contains cos x. So it is this term. So I'll have r sine alpha cos x plus what? R cos alpha sine x. Is that okay? From there, I'll have what? This implies my r will be equals to what? The square root of what? A square. Here it is minus b plus minus b square. Is that okay? Which is the same thing as square root of a square plus b square. Is that okay? Now, if this must be identical to this is sine alpha. Don't forget, this is sine alpha, this is cos alpha. If this must be equals to this, since there is cos here and cos here, it means that our a must be equals to what? Our a, which is sine, must be equals to what? R sine alpha. For this other one, there is sine x here and sine x here. This implies our minus b must be equals to what? R cos alpha. Is that okay? This implies then that we're going to have our r being equals to the square root of a square plus b square. Our sine alpha will be equals to what? A on r. Don't forget your r is a square plus b square. And our cos alpha will be equals to what? Minus b on r. Is that okay? From there, this implies my r will be equals to what? The square root of a square plus b square. Is that okay? Now, to find alpha, I'll divide sine by cos. So I'll have tan. When I divide sine by cos, I'll have tan alpha. When I divide this equation by this equation, I'll have tan alpha being equals to a on r divided by minus b on r. So this will be equals to what? Minus a on b. From there, it implies that what? It implies your r will be the square root of a square plus b square, and your alpha will be the tan inverse of a on b. So from there, after finding your alpha and your r, you will just come and substitute it where? You substitute your r here and your alpha here. You will have converted this into this. That's how you are supposed to do things. This is a very important thing I want you to note. Now, having explained this, let me go to the exercise now. Let's go back to the exercise. Okay, let me go back to the exercise. Okay, in the exercise, our aim is to find what? Is to show that this integral is equals to what? This integral. Okay, I want you to remember that when we were integrating sec x dx, when we're integrating sec x, which is the same as 1 all over cos x, the integral gave what? The integral was equals to ln of the absolute value of sec x plus tan x plus k, or it is equals to ln of the absolute value of tan x plus pi on 4 plus the constant k. Now, I know you are asking yourself, but what is the use? What is mainly the use of us remembering this? Look at something. This is what I'll do. This is what I'll do. I'll do, if you look at this, what is in the bottom here, it is in the form what? A cos x plus b sine x. Is that okay? So my aim will be what? I'll try everything possible to convert this what is in the bottom here into something of the form r cos x minus pi. That's what I'll do. I'll try to convert this into something of the form r cos x minus pi. So that's our objective. So let's transform this into something of the form r cos x minus pi. We know that we want that this, the first thing we have to write is we want this to be identical to what? R cos x minus pi. So this implies this will be identical to what? I develop this one. This will be r into what? Cos x cos alpha plus sine x sine alpha. Is that okay? This implies this. So I'll write this back as cos x plus sine x being identical to what? Since I'm starting here with cos x, I'll start with the term that contains cos x. So this will be r cos alpha cos x plus r sine alpha sine x. Is that okay? Now, for this, we apply what I've been explaining since. For this to be identical to this, what should be the condition? Firstly, r must be equals to the square root of what? A squared plus b squared, which will be equals to, our a here is what? 1. Our b here is what? Plus 1. So that will be 1 squared plus 1 squared, which is equals to what? Root 2. Is that okay? The next thing is what? There is cos here and there is cos here. This means this one must be equals to what? R cos alpha. R cos alpha equals to 1. Is that okay? There is sine x here and there is also sine x here. So this one here, the constant here must be equals to what? R sine alpha. Is okay. So that's why I wrote R sine alpha being equals to 1. This implies that our R will be equals to root 2 and our cos alpha will be equals to what? Cos alpha is 1 all over r. Our r is what? Root 2. So cos alpha equals to 1 over 2. And sine alpha will be what? 1 all over r. Our r is what? Root 2. So sine alpha equals to this. This implies what? Our r will be equals to root 2. We divide this by this. We're going to have tan alpha being equals to 1. From there, we have what? R being equals to root 2 and alpha being equals to what? The tan inverse of 1 is 45 degrees, which is pi on 4. So sine x plus cos x can be written in the form what? Root 2 cos x minus pi on 4. Very interesting. So what does it mean? It means that this integral reduces to what? The integral of 1 all over. I'll replace this by root 2 cos x minus pi on 4. Is that okay? I'll put my 1 on root 2 outside. Now, this is dx. How do I integrate this? In the previous integrals, our angles were always simple angles. There were not linear combinations of things. You understand now? There were always things of the form 3x, 5x, x. So we in the previous exercises we have been doing, we were not always using the substitution t equals to something equals to tan of something when we had things like this. We had never seen things like this. So how do you handle things like this if you are asked to integrate something of this form? The first thing you have to do is what? You let u to be equals to what is inside here. I let my u to be this. This implies du will be what? D of this. That's it. Now, when you differentiate this implicitly, you have 1 times dx. When you differentiate pi on 4, you have 0 times dx. So we have du being equals to what? Dx. So this implies this integral, 1 on root 2 integral of this, will be equals to what? Dx will be equals to what? 1 on root 2. We saw that our dx is the same thing as du. So I replace my dx by du and this by what? U. Now, from there, if you want, you can, from here, you can already do the substitution. You can let your t to be equals to what? Tan u divided by 2. and you do what we usually have to do. You understand? But for me, there is no need of doing it here because I can remember that this is a known formula. I can remember that the integral of 1 all over cos u du is the same thing as the integral of sec u du. But what is this? Recall that the integral of 1 all over cos u du, which is the integral of sec u du, is what? Ln of the absolute value of sec u plus tan u. Do you now remember? Do you now see why I was talking about this? You understand? So we know that this integral is equals to this. So this implies 1 all over root 2 integral of 1 over cos u du. The answer is what? But what was our u? Our u was equals to, remember here, we let we let our u to be equals to what? X minus pi on 4. So where we see u replaced by what? X minus pi on 4. So this implies this integral, which is equals to the integral of what? 1 all over sine x plus cos x dx will be equals to what? 1 all over root 2 ln of, where I see u, I replace by x minus pi on 4. X minus pi on 4. So I will have 1 on root 2 ln of the absolute value of sec x minus pi on 4 plus tan x minus pi on 4 plus our constant of integration. Have you seen how we integrated this? So that's another way. This is another way of integrating this. You understand? This is another way of integrating this. So take note of this exercise. This was the second method I wanted to show you. This is something that you guys have seen already in trigonometry, if you guys have done already trigonometry. So this must not be something which is strange to you. So take note of how I taught you. Take note of, where is it? How I taught you to convert an expression of this form into any of this form. Take note of the approach. Secondly, take note of, there's something you have to take note here. Take note of how to integrate things of this form. If they ask you to integrate, for example, 1 all over, let's say, cos x minus, let's say, pi on 2. Let's say, for example, cos x minus pi on 2 dx. The first thing you are supposed to do is do a change of variable where you let u to be equals to x minus pi on 2. Then your du will be dx. This implies this integral of 1 all over cos x minus pi on 2 dx will be equals to what? Integral, my dx is du, will be the integral of du all over what? Cos u. You understand? From here, you can already use what? A substitution of t being equals to what? Tan of u all over 2. And you integrate as we used to integrate. Is that okay? Is that okay? So, you can also identify directly that this integral. But if they ask you, it usually depends on the number of marks. If there is much marks, you will have to prove to show that this integral. Is that okay? You have to calculate it normally, because as we integrate sec x, because this is 1 on cos u, that is 1 on which is integral of sec u. Is that okay? So that's how you are supposed to do things. The same thing, if they ask you to integrate 1 all over cos square x minus pi on 4. The first thing you are supposed to do, you choose a change of variable. You let your u, first of all, to be equals to what? X minus pi on 4. This, your du will be what? Dx. This implies this integral, this is dx, this integral will be what? Du is dx, so it will be the integral of du all over what? Cos square u. Is that okay? And you know that to integrate something of this form, what do you do? What do? You use the substitution t be equals to what? T being equals to what? Tan of the angle that is inside, that is tan u. Is that okay? So, and don't forget to always leave your answer in terms of what was given, because when you finish integrating this, your answer will be in terms of u. Is that okay? No, when you do the substitution t, your answer will be in terms of t. You have an answer in terms of t. Don't forget that your t was equals to what? This. So your u will be equals to what? The tan inverse of t. But remember also that, so your u, where is it? So, no, there's no need here. You have your answer in terms of t, but remember that your t was equals to what? Tan u. So your answer will be in terms of tan u's. But don't forget that your u was what? X minus pi on 4. You will come and substitute it in the answer you will have. So take note of this exercise. Take note of this exercise. Try to do this exercise about 2 or 3 times for you to master carefully all the hints I gave in this exercise, starting from the first video to this video, starting from the first method we did to this second method we did. So see you in the next video. We are going to do which exercise? We are going to do this exercise. We shall enter into part 3. We shall do this exercise. Understand? We shall prove this exercise. We shall also do this other one. So we are left with this exercise, and which part again? We are also left with this exercise also. Yes, this exercise, and which exercise again? And this last exercise. In the next video, when we shall be doing this exercise, I will show you 2 techniques to solve this particular exercises of this form. I'll show you how to solve these exercises. So see you in the next video, trying to go back through all these exercises and try to master the techniques that are being taught in them. So see you in the next video.